Welcome back again to a professional class on accountancy certifications. So, we will continue with our topic on linear programming. This time around, we'll be looking at how to formulate an LPP. LPP means linear programming problems. How do we formulate problems involving linear programming? In formulating problems involving linear programming, the following steps are involved in formulation. Number one, define all variables and their units. So you must be able to define all variables. For example, the products we want to produce, product X, product Y. What quantity is presumed to be produced? 100 units of product X, 150 units of product Z. Then other variables like material A. Material A, the amount available is 2,400. So which means that material A can either be less than or equal to 2,400 but cannot be greater than that. So define all your variables: material A, material B, material C. After defining all variables and their units, 100x, 150y. Then the next thing is determine the objective of the problem. Is it to maximize profits or to minimize cost? That is it either to maximize or to minimize the objective function? After determining this, express the objective function mathematically. You know, that's what we are talking about the other time, that the objective, express it in a mathematical function. Then it becomes an objective function. So after ascertaining the objective of the firm, then express this objective in a mathematical function. After that, express each constraint mathematically. Express each constraint mathematically, including the non-negativity constraints, which are the same for all linear programming problems. The constraints are always expressed in inequalities. So after expressing the objective function mathematically, then take each of the constraints and express them in mathematical function alongside. As you have expressed the objective in a mathematical function, express this constraint, which is as a result of scarce or limitations on the input component, express them also mathematically. And finally, don't forget to express all these input element or input component as a non-negativity constraint. That is, always say that x, y, z is not equals to 0. So, which are same for all linear programming problems. And don't forget, all this must be expressed in inequality. This is the last of the formulation of linear programming problems. Lastly, before rounding up this episode on linear programming, we'll be looking at what are the methods involved in solving linear programming problems. Now, to solve linear programming problems, for the purpose of this class and this level, there are basically two methods that could be used. We have what we call the graphical method and the simplex method. The graphical method or the simplex method. For the purpose of this class, we'll not be looking at the simplex method for now, but we'll only be looking at the graphical method. Now, what are the steps in applying the graphical method in solving a linear programming problem question? Number one, after the formulation of the linear programming problems as outlined or as explained initially. The first thing you do is that turn all the inequalities. Don't forget I mentioned something like greater than or equal to, or less than or equal to. Turn all these inequalities, change them to equalities. That's number one. Step 2, draw the lines representing the equation on the same axis. By the time we are actually looking at the workings aspect, we are going to get a full grasp of what this entails. So, draw the lines representing the equation on the same axis. Step 3, identify the region where each constraint is satisfied. This region is what we refer to as the feasible region. Now, on your graph, there's going to be a region where all these lines, which are representing each of the constraints, there will be a region where they all intercepted, or there will be a region where all these lines are all confined within the region. This region is what we refer to as the feasible region. So identify this region. After identifying this region, then identify the region where all the constraints are simultaneously satisfied. That's what I mentioned earlier on. This is called the feasible region. After identifying this feasible region, find or read off the coordinates. That is, trace their coordinates both to y-axis and the x-axis, then take out each value. For example, if we have point A, point B, point C, point D. Point A, we have its own x and y axis. X and y coordinate values. B, we have its own x and y coordinate values. The same for C, the same for D. Read out these coordinates. Then the next step, calculate the value of the objective function for each of the points by substituting each of the coordinates in the objective function. So each of the coordinates you've actually read out, either for A, for B, for C, or for D, substitute them inside the objective function. Now, after substituting them in the objective function, the last step is this. Then determine the optimal solution, which is the point with the highest value of the objective function for maximization problems, or the point with the lowest value of the objective function for minimization problem. So, if you are dealing with a maximization problem, either after inputting the coordinate of A or B or C or D, the coordinate that gives you the highest value of objective function is what we refer to as the optimal solution. That is, the value of y and the value of x at that point is the optimal solution. Also, correspondingly, if you are dealing with a minimization problem, whatever coordinates of the point, either A or B or C or D, that gives us the lowest value, minimization, cost, minimization. All firms want to minimize or reduce their cost. That gives the minimum value or the lowest value of this objective function is what we refer to as the optimal solution. So the coordinates at this point is the optimal solution. So I don't believe you've been able to enjoy quite a lot of things and lectures and intellectuals that have been delivered unto you in this linear programming problems, as also in previous episodes on marginal and absorption costing, on cost volume profit analysis, on capital budgeting and investment appraisal. I believe you've been able to learn a lot in all this. So I want to say that you're going to be doing us a lot of favor and also yourself by following up with our videos, our lecture classes, our presentation slides, both on YouTube. Subscribe to the YouTube channel to be availed and be alerted and be alarmed of upcoming videos. Like our videos and share our videos to all your loved ones and professional colleagues. And also, don't forget to check up our website, learncity.com, where the archive and the arsenal and the packages of all this wealth of knowledge and learning resources has been made readily available and accessible for you. Don't forget to access our website so that you'll be privileged to make use and utilize these resources to the optimal